So it turns out that unfortunately this is no useful approximation factor at all. And the reason for that is that the approximation factor depends on the size of the minimum vertex cover for the input graph. So the first thing to notice is, of course, that it's not a constant factor approximation algorithm, because we can be given any graph, and that graph can, of course, have different size vertex covers. Let's say we wanted this to be at least a factor 2 approximation algorithm. What that would mean is that 1 plus k over n minus 2k is smaller than or equal to 2. So when you solve this, what you get is that k must be smaller than or equal to n thirds. Now, seeing this, you might be inclined to think, why isn't this answer here correct? Because if k, which is the size of the smallest vertex cover, is less than or equal to n thirds, then most of the vertices are in an independent set. So the answer could be, if the independent set is very large, then we also have a good approximation algorithm. But the problem of that is, of course, that in order to really assess the quality of the approximation, you need to have an exact solution. And if you already have an exact solution, then approximation, of course, makes no sense anymore. So it's an approximation factor that can only be determined in hindsight once you have calculated an optimum solution, in which case you don't need the approximation anymore. So this here is also not a correct answer. And the unfortunate thing is, it's actually not a useful approximation at all.